بسم الله الرحمن الرحيم رب زدني علما.
Similar way, there is one more value called delay. Now, delay is used in the metric calculation by default. Now, delay means, the normal term delay means how late or how long it is going to take. Now, which means here, it's going to be like the time taken by the packet to cross that particular interface. Means when the packet is crossing this interface, it's going to take how much time. So it will be calculated in the fraction of seconds in case of milliseconds. So milliseconds generally. So here it will be in microseconds actually, not milliseconds. So like 1 second is equal to 10 milliseconds, and then 1 millisecond is equal to again microseconds. So it's lesser than millisecond. And there are default, and this delay value is actually a fixed value. Now, fixed value means this will not change unless you go and manually change. And there is a default delay, like for the serial links, the default delay will be 20,000 microseconds. And for the Ethernet, it will be 200 microseconds. And fast Ethernet, it is 100 microseconds. And for gig Ethernet, it is 10 microseconds. And it is expressed in tens of microseconds, which means if I want, I can go and change the delay. And by default, this delay value is being used. It is enabled, which is K3 is 1, K1 is 1. K1 is bandwidth, K3 is delay. So these are the two values which are used in the metric calculation. And if you want, we can go and change the delay. Like if I go to my interface, and if you verify the default delay on the serial link is 20,000 microseconds. And if you want to verify on the Ethernet link, it will be, now here you can see the default delay on the Ethernet, fast Ethernet link will be 100 microseconds. So let's say I want to change the delay on the serial link. I'm going to serial 1/0. And again, it is a fixed value. This will not change unless you manually change it. And by default, it will consider the delay, what is the default delay, whatever is present on the interface. Like I think it is 20,000 microseconds on the serial interface here. So I'm going to change the delay to 1,000. So if I just apply 1,000, it is going to apply tens of microseconds, which means if I say 1,000, it will automatically use tens of microseconds. So the delay will change to 10,000 microseconds. If you verify show interface, you'll see the 10,000 delay will be changed. So the default way you represent is tens of microseconds, which means if I'm applying the delay value of 1,000, it will automatically into multiple 10. So just like this example here, if you want 1,000 microseconds, then we need to apply 10 microseconds. Sorry, 100 you have to change. So when you change with a delay of 100, then at the end it will apply 1,000 microseconds. Like in my example, I have changed the delay to 1,000, then it will apply 10,000 microseconds automatically. And again, the delay is something used. By default, it is enabled. And finally, there is something called MTU. MTU stands for maximum transmission unit. It's a kind of maximum size of the packet. So by default, it is going to advertise this MTU information as well in the routing updates. So we call it as K5, and by default it is disabled. So MTU is also not considered in the metric calculations. So if you see the summary of these values, so we have something like K1, K2, K3, K4, K5. So as per the EHRP calculations, or EHRP is going to calculate the best route or the cost based on 5 different factors. And by default, this K1 is enabled and K3 is enabled. So remaining all values are zeros, which means they are not used in the metric calculations. So if you go with the default values, like this is the formula, and if I assume that K1 is 1, K3 is 1, which are being used, and the remaining values are not used, then the formula will go like this, and it is going to write down these values, whatever the bandwidth here, and then delay right down here. And then it will calculate the metric, or it will calculate the cost, and you get these cost values. So of course, we don't need to calculate this. Automatically, the routing protocol will take care of these options. So mostly what we'll be doing is you may go and change the bandwidth on that particular interface as per the requirement, or you may also want to change the delay if you want to influence the best paths. So depending upon the bandwidth and the delay what you are using, you get this cost values. So it depends on this. So these are some of the values which you get normally. Depends upon the link speeds. So normally, if you just take a simple example to understand the metric calculation here, as I said, we'll be using only delay and the bandwidth are only used in the metric calculations. But again, if you just want to have an idea, like good to know, like you can see the topology here. We do have multiple paths in my topology. And I want to figure out in this topology, what are the different values used? Like there's a delay on the specific interfaces, and there is 1.5 Mbps link here, the T1 line. Now, what will be the summary delay or the summary bandwidth used here? Now, always we need to remember the overall delay will be always the sum of all the delays, which means in this example, if you're going from one path, like from A to D, this is one path. Now, from this path A, B, C, D, so the default bandwidth, it is going to consider the least bandwidth. So whatever the bandwidth it is going to use in the formula, that will be the least bandwidth, which means this is 1.5 Mbps, this is 1.5 Mbps, and this is 64 kbps. So when it is calculating the best route, it is going to consider the minimum bandwidth here, that is 64 kbps. And what will be the delay? So delay value also is used here. So the delay value will be sum of all the delays, which means the delay will be 2000, 2000, 2000. So sum of all the delays will be 6000. So it will be used 6000 here. A similar way, if you take the another path on this particular path, so the minimum bandwidth, if you observe 256, 256, 256, all are 256, so it will consider 256 bandwidth, and the delay will be 8000 because of the sum of all the delays. Okay, so that's how the formula goes. So this is something we just need to understand, and based on these values, it will extract one number. We call that number as a cost. And let's assume there are two possible routes. So if you go from ABC, let's say the cost extracted based on the calculation is 1000, let's say, and the cost you get from the other path is 2000. So the EHRP is going to consider the least cost as a best route, which means the best route will be this one based on the least cost. And you will see these cost values when you verify the routing table. When you say show IP route, you see these are the specific subnets, and D represents the routes which are learned from EHRP. And then this 90 is the administrative distance, and you see these values cost here. So the cost values you see here. Now these cost values are completely based on the calculation again. So it is going to do that automatically. Like in my case, in my topology, if I say show IP route EHRP, you can see the cost values here. So this cost value is to reach the 20 dot subnet from the router 1. And it is based on the bandwidth and delay. So if I change the bandwidth, automatically the cost will change. So let me see what is the bandwidth here, 1000. So I think I have configured the bandwidth over this. So I'll go and change the bandwidth to, let's say 512 or 256 kbps. So if I change the bandwidth to 256, if I verify the show IP route EHRP, you should see the cost will automatically increase, because the lesser the bandwidth, the cost will automatically go high. So it's like opposite, inverse proportional to that. So similar way, even if I go ahead and change the delay value as well, even if you change the delay also, the cost will impact. So these are the two values which can be used, or you can change if you want to change the cost values. But normally we decide based on the bandwidth. So you delay, most of the time you always prefer to go with the default delay values, what you have on that. And the bandwidth, you always want to change the bandwidth as per the interface bandwidth provided by the service provider, especially on the WAN links.